Let's say you want to buy a new computer and you are given two options, Company A's laptop or Company B's laptop. You are told that the mean battery life for both laptops is 4 hours. If all other specs are the same, which one do you pick? Well, it doesn't matter. As far as you can tell, it's the same laptop sold by two different companies. What if we were now shown the data used to calculate each laptop's mean battery life? Which laptop would you choose now? Company A's. Why? Because more of their trial laptops reported having a battery life closer to 4, meaning more data points were centered around the mean. If we look at Company B, we see that though the mean is 4 and some data points are centered around it, most of the points are spread across the graph. So one way to choose the better computer is to pick the one with less spread in its data. So we can see that given the mean alone can be useless, we must also figure out a way to quantify the spread of the data. One way we can quantify the spread is by considering the range. This is when we take the largest data value and subtract from it the smallest data value. So what we are doing here essentially is taking the distance from the furthest data value and 0, then subtracting from it the distance from the smallest data value and 0. The issue with this method is that it is highly sensitive to Imagine if we had 1,000,000 points centered around 4. Then the mean would be 4 and the range would be 0. Meaning there is no variation in our points. Now, imagine if we had 1,000,000 points centered around 4 and then 1 point all the way at 14. The rounded mean would still be 4, but the range would be 10. The data is essentially the same, but one can mislead someone just looking at the range. We need to find something less sensitive to outliers. Instead of taking the distance from 0, let's take the average displacement from the mean. This will give us a better frame of reference. However, what often happens is that all the points will end up canceling each other out, leaving us with a 0 in the numerator. So we're headed in the right direction, but we just need to avoid all the points canceling out. Another thing we could try is taking the absolute value or the distance to the mean. This will eliminate all negative measurements and keep the numerator some positive figure. This looks good, however, it fails to preserve the uniqueness of our data. Meaning a data set that has different valued points could have the same distance to the mean. So let's recap what we want. We want to measure the spread of a data set while preserving its uniqueness and keeping our numerator positive. The only other way I can think of to make any number positive is to raise each number by an even power. Let's use the simplest of these, the square. I'm going to take the mean of the square displacements. And now everything works. It preserves the uniqueness and leaves us with a positive numerator. This formulation is called the variance and is denoted by sigma squared. But there's one issue. Look at the units left over. What the heck does hours squared mean? I have no idea. But don't worry, that's an easy fix. I'll just take the square root of my answer to turn our units back into hours. This is the average distance to the mean, and it has a special name. It's called the standard deviation, and it's denoted by sigma. Note, there are two formulas, one for the population and one for the sample. In the population, you divide by the total number of items in the population. In the sample, you divide by one less than the number of items in your sample. Let's say you bought a laptop from company A, and it turns out that it only has 1 hour of battery life. Is this a ridiculously low amount of battery life to expect? Well, we have a way to quantify ridiculously low and ridiculously high values. We say that something is significantly low if it is 2 standard deviations or less away from the mean. And we say something is significantly high if it is 2 standard deviations or more greater than the mean. Since 1 hour is not less than 0.54 hours, we would say that it is not ridiculous to expect this battery life.